Today we will continue to discuss inequalities and compound inequalities, but we will look at a new way, possibly a simpler way, of writing these inequalities. So let's get started. So interval notation is a way to write inequalities using brackets. So these are brackets. We can have an open bracket and then a closing bracket. We can also use parentheses. We have an open parentheses and a closed parentheses. And we use these brackets and parentheses instead of the inequality symbols. So in this first example, we have the graph of the compound inequality, x greater than 1 and x less than 5. So with x greater than 1, we have all the numbers greater than 1. So that goes from 1 to infinity. And it does not include the number 1. Then with x less than 5, we have all the numbers less than 5. This goes on to negative infinity. And once again, this is less than, so it does not include the number 5. We're using the word and, that key word. So we're looking at the intersection of these two inequalities. And that's going to be everything between 1 and 5, excluding 1 and 5. Now we can write it this way, where we combine these two inequalities into one. And we read this by starting in the middle. So we have x greater than 1. We were reading right to left that time. And x less than 5. But we can also write this using interval notation. So what we're going to do is we're going to write the left boundary. In this case, that left boundary is the number 1. The right boundary is the number 5. And we're going to use parentheses to show that neither 1 nor 5 is included in this interval. So we use parentheses when the number is not included. Let's try another. Here we have the inequality x less than 6. So in this case, we have a right boundary of 6, but there is no left boundary. This continues forever to negative infinity. So we'll place a negative infinity here. 6 is not included, so we'll use a parentheses. And then we also use a parentheses with either infinity or negative infinity. So this right here, 1 comma 5 enclosed in parentheses, represents the numbers between 1 and 5, but does not include the numbers 1 and 5. Whereas this notation, where we have negative infinity, comma 6, enclosed in a set of parentheses, represents all numbers less than 6, but again does not include the number 6. Let's try another one. And in this case, we have a closed circle, so these endpoints, these boundaries, will be included. So we have x greater than or equal to negative 2 and x less than or equal to 7. We can write this in this condensed notation. Again, we'd read this the exact same way as the one above it. We'd start in the middle with the variable and then read from right to left, x greater than or equal to negative 2, and back to that x again, and now from left to right, x less than or equal to 7. But let's write this now with interval notation. Our left boundary is negative 2, and since this is less than or equal to, negative 2 is included, so we're going to use these square brackets. Then we'll place a comma. Our right boundary is the number 7, and it's also included, so we'll use another square brackets. So we use square brackets when the number is included. This notation here, -2, 7, represents the interval of all numbers between -2 and 7, including both -2 and 7. Next, we have x greater than or equal to 0. So we have a left boundary here at 0, and 0 is included. We have the closed circle, and then we have all numbers bigger than 0. And this is going to extend to positive infinity. To write this in interval notation, we'll write down that left boundary, which in this case is 0. We'll include 0, so we'll use a bracket, and then comma, and then this goes on to infinity. So we'll use the infinity symbol, and then parentheses. We will use parentheses with both infinity and negative infinity. Let's practice a few more that use and, these intersections that the inequalities have in common, where they overlap. So we have the compound inequality x greater than -4 and x less than or equal to 1. And this is the graph of that compound inequality. So the left boundary is -4, and we do not include it, so we'll use a parenthesis. And then the right boundary is 1, and that is included, so we'll use a bracket. So we have the interval of all numbers between -4 and 1. -4 is not included, but 1 is included. Next, we have x greater than or equal to 0 and x less than 6.5. So this is going to work for all real numbers, not just integers. Our left boundary is 0, and 0 is included. And then the right boundary is 6.5, and it is not included. So we're going to use a parenthesis here. So now we have the interval of all numbers between 0 and 6.5, including 0, but not including 6.5. So when we're using interval notation, we can use both parentheses and brackets for the same interval. Now moving on to or. So when we're talking about the keyword or, the final solution set will have all numbers that is in either of the two inequalities. So for this first inequality, we have x less than -3. So we have -3 as that right boundary, and -3 is not included, so we'll use a parenthesis, and put a comma, and then this is going to extend all the way to the left to negative infinity, so we'll use our negative infinity symbol, and then with infinities, we use parentheses. For this second inequality, we have x greater than or equal to 2. We have a boundary at 2, and 2 is included, so we'll use a bracket. Then we have a comma, and then this will extend all the way to the right to positive infinity. So again, we'll use that infinity symbol with a parenthesis. And then to show that these two are connected, to show that or keyword, we're going to use this symbol that kind of looks like a U. That stands for the union of these two intervals. So the union of two sets of numbers uses the keyword or. And so for the second problem, using the union of two sets of numbers, we're using that keyword or. And the first inequality is x less than or equal to 0. So we have 0 as that right boundary. And 0 is included, so we'll use the bracket. And we have a comma, and then this extends to negative infinity. And then that uses a parenthesis. And then with the second inequality, we have x greater than 4. So we have 4 as our boundary. 4 is not included, so a parenthesis, comma, and then this extends all the way to infinity. Again, this is the union, so we'll use this U-like symbol. So now let's look at some special cases that may not be obvious until after we graph them. So we're going to start by graphing them. So we have x less than or equal to 8. So we have a closed circle at 8. And then we'll have all numbers less than 8. So that's going to go on to negative infinity. Then we also have x greater than negative 6. So we have an open circle at negative 6. And then all numbers bigger than negative 6. So that's going to go on forever in the positive direction. So these two intervals overlap. So this is going to go on forever in the negative direction. And this is going to go on forever in the positive direction. This is an OR statement, so it only has to be in one of those intervals to be included. So this is the entire number line. And to write the entire number line using interval notation, well, it's going to have no boundary to the left, so that's just going to go on to negative infinity. And it's going to have no boundary to the right, so that is also just going to be infinity. So this means all real numbers in interval notation. So all numbers on this number line, extending all the way to negative infinity to the left and positive infinity on the right. All the integers, all the fractions and decimals, all the irrational numbers, pi, they're all going to be within this interval that goes from negative infinity to positive infinity. Now let's look at x less than 1 and x greater than or equal to 3. We'll start by graphing it. So at less than 1, we're going to have an open circle. And then these are going to extend all the way to negative infinity. Next, we have x greater than or equal to 3. We have a closed circle at 3. And then all numbers greater than 3. So this is going to extend all the way to the right to positive infinity. This is an AND statement. So we need to look at where they intersect or overlap. There is no overlap. There's no numbers that are in both of these inequalities. So we're going to write this as an empty set. So here we have no solution. There is no number x that is both less than 1 and greater than or equal to 3. A great way to learn is to practice on your own. We will discuss in a bit, but go ahead and pause your screen and do these 4 problems. Okay, so for this first problem, graphing this, we have x greater than negative 4 and less than or equal to 7. So this is the interval from negative 4, not including negative 4, so we'll use a parentheses, to 7. And 7 is included, so we have a bracket. In the second problem, we have x less than 1 or x greater than 5. So at x less than 1, we're going to extend all the way to the left. We're going to use the negative infinity symbol, comma, and then our boundary, our edge is 1, but 1 is not included. For the second inequality, our left boundary is 5. 5 is not included, so we're using parentheses. And then this extends forever in the positive direction, so we'll use the infinity symbol. This is an OR statement. This is a union, so this is the symbol for union. Next, we have x greater than or equal to 0 and x less than or equal to 1. On this number line, this is a small interval that includes all numbers between 0 and 1 inclusively. So 0 and 1 are included, so we'll use those brackets. And then finally, we have x greater than 0 or x less than or equal to 7. So x greater than 0, we're going to have an open circle at 0, and that's going to extend forever in the positive direction. with x less than or equal to 7, we'll have a closed circle at 7, and then that's going to extend forever in the negative direction. Combined, they represent the entire number line. So we're going to use the interval from negative infinity to infinity to represent all real numbers. Continue practicing working with inequalities, and I'll see you in the next video.